Okay, so here we are going to start today doing properties of equality. A lot of this is going to be really not anything new or not anything like mind-blowing to you, but it's very, very, very important that we get these down and we can recognize them and name them how they are, because as we continue the week, we're going to start into proofs, which basically just says, hey, I can prove that this statement is true because of these reasons, these properties. So we have to get these down because these are going to be the explanations or the meaning for why a step is true. So we have all these properties of equality, and they basically are saying that one part of it, an equation or expression, will be equal to another piece as long as it happens on both sides of the equation. So basically what we're saying is for addition, these first four, probably the first five, are going to be fairly straightforward and like not anything really new. These new ones down here that you probably haven't seen those names before, you will see them and understand what they mean because we have actually done them in class. We just haven't named them anything. So to start off, addition property is pretty easy. If A is equal to B, so some value for A is equal to some value for B. It can be 2x equals 2x, whatever. Or it can be 5 equals 5. Then for addition, it's saying that this will still be equal as long as I add the same value on both sides of that equal sign. So I add to both A and I add the same thing to B, and they will remain equal. So if I said A and I add in, let's say, C, that will still be equal to B as long as I add C on that side as well, because they both had an addition. The same will be true for subtraction. A is equal to B, and those will remain equal to, if I'm using subtraction, as long as I subtract, oops, not A, this is B. As long as I subtract the same value on both sides of my equal sign. I'm going to take a sip of water. All right, multiplication. We have A equal to B again, and these will remain equal to, even with multiplying, as long as I multiply the same thing on both sides. So I multiplied C on both sides. These will remain equal to. Division, A equals B. This will remain true as long as, again, you divide by the same thing. On both sides, I divided by C. Distributive property. So this one, I know those of you who had me, we did this a lot last year. I'm pretty confident we've looked at it this year. I just really can't remember. But I know for a fact we did a lot of it last year. So this is saying A parentheses B plus C. So if that, then A times B plus C is the same thing as saying A times B, which is AB. It has addition in the middle of my parentheses, so I add A times C, which is AC. So this distributive property would be the same thing as A times B plus A times C, because that's all you're doing is multiplying when you distribute those. All right, substitution. So this one is a new word, but not a new thing. So we still have A equal to B. This means that it can be replaced. So we found A equals some number B, and it can be replaced with any expression or equation. So this is like x equals 5, and you have an equation 2x plus 1. You can go change that value of x to what we just found. When we've been graphing in Desmos and find what x is equal to, and then go and find the missing length for a line segment, that is substitution. And we'll look at this without it being all letters in a second. We'll use numbers. All right, reflexive property. So this one is for any real number A It's basically saying that A equals A. Some number is always going to equal itself. That one's pretty easy. All right, symmetric property is also very easy. It says if A equals B, well, then it must be true that B is equal to A. If X equals 1, then 1 is equal to X. You can write it in any way, and it still means the same thing. And transitive property is if A equals B, and then now we have B is equal to C. So let's pause here. We have some number equal to B. And then we have B also equal to some other number. So notice that we have B in both of these equations being equal to something else. So when that is the case, when there's a number like the same piece equaling two different pieces, that means that those two different pieces are equal to each other as well. Think about it. If A is equal to B, so let's say that this is 5 equals 5. So B is 5. Well, if I come here, B is still 5, so it has to be equal to C, which is also going to be 5. So B equals 5, and C equals 5. So since these were both equal to B, which is 5, that means A and C must also be 5. All right, let's look at some actual examples, though. Wait, not that. Not that. This. All right, properties of equality examples. So we have all of those properties listed out here, and then we have some actual algebraic written out examples. So if we go through the list, we're just going to pick which one of these is going to be our correct answer. So the first one, if 4m plus n equals 7 and n equals 3, then 4m plus 3 equals 7. That's a lot of numbers, a lot of letters, a lot of what is going on. Basically, what you're saying is, how did I get from this first if statement, my hypothesis, to this then statement, the conclusion? Well, we see here we started with 4m. We still have 4m at the end. We have plus n, but now we have plus 3. So what happened is it told us that this value of n is 3. So instead of including n again, it changed that value of n to 3, which is exactly what substitution is saying. If you know the value of n, you can replace that variable, that letter, with the number. So since n was replaced with 3, this is substitution. All right, number 2. If a equals -5, then 2a equals -10. So this is saying, okay, we have this value of a being -5. Then how did I get this 2a to be equal to -10? What did we have to do to get basically -10? Well, we had to multiply 2 times a, right? We say 2a because it's easier, but really these two are being multiplied. 2 times a. So 2 times -5 gives me -10. Since we had to multiply to get our answer, our equality, or property of equality, will be multiplication. So letter C. Number 3, if 3x equals y, then y equals 3x. So let me scroll down here. Okay. So we have 3x equals y and y equals 3x. So we notice, okay, what happened from here to get to the then statement? Well, we noticed that it basically just flipped around. It still is 3x and 3x, but they're on the opposite sides of the equal sign. So whenever it flips around like that, if we look back, here, symmetric a equals b, then b equals a. That is our property, where it flips. It's just saying that either way that you write it, it means the same thing. So symmetric for that one, letter H. Number 4, if 4w minus y equals 11, then 4w equals 12. So 4w minus y equals 11. How did we get from here to 4w equals 12? Well, I see I still have the 4w, I still have the 4w. I no longer have this -1 or 11. It now became a 12. So what happened is they added 1 to each side of the equal sign and got 12. So since we had to add from this step to get to this step, our property of equality is the addition. All right, number 5. If A plus B equals C and C equals D squared, then A plus B equals D squared. So this one here is one of our newer ones where we have this phrase A and B. When I combine those two, they're equal to this value of C. But it's also saying that this value of C is equal to D squared. So if we remember, when we have two different pieces equal to the same variable, so in this case, these are both equal to C. You can see those are both included here. Reflect back on this last one. A equals B, B equals C, then A must equal to C. This one must equal to this one. It's the same thing here. We have this first piece A and B equal to C, and we have D squared equal to C. So since they are both equal to that same value, C, they have to be equal to each other. So that's how we get to this. A plus B equals D squared. So that one was transitive. All right, number 6. 6y equal to 6y. Well, it's itself equal to itself, so if we reflect back, we said here, any real number for A is equal to A. So if it's the same on both sides of the equal sign, it's reflexive. All right, number 7. If -8 equals -56, then Q equals 7. So we have -8 times Q. Okay, I'm sorry, I don't remember where I left off. There was an announcement, so I paused. But we have -8 times Q equal to -56. So we have this equation, and we need to figure out how do we get to this Q equals 7. Well, notice that we no longer have the -8, and we no longer have -56. So what we had to do then is do the opposite of multiplying when we're solving the equation, and we had to divide. So -56, if I divided by -8, gives you a +7. So the step they did from here to get to here is division. For number 8, if 5k equals -25, then 5 minus 1 equals -25 minus 1. Well, you can tell that they took on both sides and subtracted -1. So since both sides are being subtracted, we will have subtraction property of equality. All right. Then here we have -3 parentheses or times 2x minus 5, and that's equal to -6 plus 15, which we know if we did -3 times 2x, we get -6x. -3 times -5, we get +15. So that is the distributive property, where you take the number on the outside of the parentheses and multiply everything inside. And that is basically all for our properties of equality.